Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Fadl Abdul Latif and my supervisor name is Dr. Zamani, and my title is Traffic Light Detection and Counter Recognition. In this presentation I'll be talking about introduction, lecture review, research methodology, results, conclusion, future work and references. As a background for this project, the traffic light systems are used to control and monitor the automobile flow through the road junctions. The countdown timer improves the traffic light system by displaying the remaining time for the current state of the traffic light. As for motivations, using smart traffic light system in vehicles would provide an opportunity to reduce or eliminate human exposure to difficult and unsafe driving and solve most safety related problems. As for problem statement, detecting the countdown timer is considered as a part of advanced driver assistance system. ADAS is a technology used in vehicles which helps drivers for driving or parking. ADAS is required to be implemented in vehicles for the purpose of providing guidance for drivers and enhancing a better safety for vehicles and roads by minimizing human error. The second point of the problem statement is about recognition. Recognition of the countdown timer of traffic light provides an input to the system of autonomous vehicles technology of the remaining time on the traffic light in order to have a more accurate system in terms of controlling the vehicle speed. As for research question, how to detect traffic light with counters, how to recognize the state and the digit of the traffic light countdown timer using a vision system. Objectives of this project are divided into three parts. The first part is to design a vision system to detect a traffic light with counter. The second point is to develop a vision system to recognize the counter of the traffic light, and last but not least to analyze the performance of both algorithms. Scope: the first point is to detect and recognize the number of traffic light from 9 to 0. The color of the traffic light specified green and red only. Detecting and recognizing the countdown timer of the traffic light during daytime. Analyze parameters of the performance are the object detection rate and accuracy of the network by using coefficient matrix. Chapter 2 Literature Review. We can see that the table has summarized 4 or 6 papers related to the detection and recognition of traffic light. For the first paper, to recognize traffic light and their signal countdown timing, method of detection, thresholding, method of recognition, horizontal, vertical scanning, while the evaluation parameters scored evaluation and accuracy of traffic light detection and LED digit recognition. As a result of that, detection and recognition has been separately calculated. Precision and accuracy for detection is 97 and 96 respectively, while it's 98 and 88 for recognition. And on the second paper, which is presented on 2020, purpose is traffic light and countdown timer detection network for autonomous vehicles. Method of detection: RGB to HSV color space together with mask RCNN. Method of recognition is Rentinet framework, precision and recall for classes 0 to 9, and as a result precision 82.20 and the recall 82.20 and 78. However, for the third and fourth paper, they have used color conversion and the method of detection, while in method of recognition the third paper used template matching measure and the fourth paper used CVM and CNN classifiers. As evaluation parameters, accuracy of detecting and recognizing red and green light from traffic light, and scored red 81.82 and 83.33 for green. For the fourth paper, accuracy, precision and recall of multi-target traffic light detection. As a result, accuracy 97.5, 98.9 and 98.6 respectively. For the last two papers, which is presented in 2018 and 2016, the purpose for the fifth one is to build up an algorithm detecting pedestrian traffic light and their state, which has used ULV2 and as evaluation parameters precision and recall for walk or do not walk status. For walk status, the precision and recall scored is 100, 94.92 and 100 for the do not walk status. For the last paper, to construct an oval vision-based traffic light detection method for driving vehicles, method of detection, adaptive background supervision, method of recognition, cascaded CVM with the HOG descriptor and RGB histogram. Evaluation parameters, precision and recall of detecting traffic light state and recognizing arrow direction. As a result, precision scored is 92.2, as a recall 94.69. According to all the related research done previously, detection process methods used to locate object and boundaries, which could be done using color space conversion and image segmentation, as I was presented in 1, 2, 3 references. On the other hand, reference 5 used YOLO, which does not require color conversion segmentation. A recognition process could be done using several methods, such as classifiers, CVM, CNN, as I was presented in 4 and 6 references, horizontal and vertical scanning, Rentinen framework, template matching measure, or by using YOLO5 for recognition process. However, in this project, the detection process, such as classifying objects and annotating them, has been done using CVAT and image pre-processing using RoboFlow. And last but not least, the model has been trained in Google Lab in the format of YOLO V5S PyTorch. For methodology, we can see the flow chart on the right side. Start by collecting videos dataset for training, then split them into frames by 30 frames per second as it's been recorded using iPhone. Annotate and classify dataset using CVAT. Match images with corresponding annotation and the required pre-processing using RoboFlow. Train model in Colab for detection using YOLO V5S, and as after that, if the digit and color correctly detected and recognized, if no, then it has to be back to taking more dataset and doing the same process again, and if it's yes, then display the detected and recognized objects with detection rate. As the total trained frames is 2600 frames, while the tested frame is 100 per category. We have about 12 categories from 0 to 9 plus green and red, so that's 1200 frames for testing. The dataset were collected from urban street and different conditions of timing and location. Total number of categories is 12, which consists of 10 categories for digit from 0 to 9, as well as red and green. Why YOLO? YOLO is a clever convolutional neural network for doing object detection in real time. The algorithm applies a signal neural network to the full image and then divides the image into regions and predicts bounding boxes and probabilities for each region. Some YOLO motivations are its accessibility, ease of training, high quality performance, and quick inference speed. YOLO V5 is the first model of YOLO which can be implemented to PyTorch. Chapter 4 result. The model was trained to detect and recognize the digit of the countdown timer as well as the current state of the traffic light by detecting the color from the arrow area. Figure 2 shows the results of the detected object. As can be seen, the digit is detected and recognized together with the detection rate displayed beside the digit recognition label. and same goes to the color red and green, which is detected from the arrow. And there's two types of digit sharpness, and which displayed in figure 2. As we can see, the left two pictures and the right two pictures, the sharpness of the digit is quite high compared to the sharpness of the middle two pictures. For the training dataset that was trained, it has been trained with the high sharpness of a digit, which means the middle two pictures, if it's been detected, it would have a low detection accuracy, as can be seen 0.17 and 0.22, while for the other digit, the sharp digit, is 98 and 88. Same goes to this type of traffic light is displaying two digit, so the system will recognize it as individually, and the detection rate is 90 and 86, and last but not least is 87. So overall, the detection rate for that sharp digit is usually above than 80, while it's less than 20 or 25 for the less sharp digit. And now let's see some of the videos which has been resulted from the model. As you can see, the system is quite following the speed of the counter, and this is one of the unsharp digit. As we can see, the detection is low, and sometimes it doesn't even detect the digit, while sometimes the number 1 could be detected as 1. And this is another sharp digit. The accuracy, as mentioned, is usually above than 80 for either for the digit or for the color presented in the red in the arrow direction. For the confusion matrix, there is two sides: actual on the left hand side and prediction on the top. We have 12 classes from 0 to 9, green and red, and for class or category number 0, the accuracy score is 100. For category 1, it's less than 100, which has been missed, as mentioned, due to the sharpness of the digit, and which that model has, or that type of digit was not included in the dataset detected previously, but instead it's been used in the testing dataset. And that's the same goes to number 4 and number 5 and number 5, number 6 and below to the red. It's all detecting it as 100 even in the unsharp digit. Chapter 5, conclusion. In conclusion, objectives of this project have been successfully completed with excellent result of detecting traffic light with counter and recognizing the digit displayed as well as the current light from the arrow direction. Evaluation of the results have been done using detection rate, which means how confident the model is of the detected object, as well as by using the confusion matrix to show the accuracy accomplished in every category. As for future work, I have come out with 3 points that I think I have to add to the present work in order to make it more advanced and more accurate. Number 1 is to train more dataset for different traffic light displayed and digit shape, as has been shown earlier in the result part. Number 2, or point 2 in future work, is to train the model to be able to detect from far distances, and point 3 is to detect the digit and the color from the presented digit only. And here's 6 references which have been used in the literature review. And last but not least, I would like to thank my supervisor, Dr. Zamani, and I would like to thank my panels, Dr. Nordiana and Dr. Faris. And thanks to all mates, and Assalamu alaikum wa rahmatullahi wa barakatuh.